Okay, I'm going to continue on my COVID report from the last video that I produced. When I finished up last time, this is basically what I had. I had a small multiple set up, and I've got these 4 different phases of COVID activity that happened within Australia. I'm going to jump back and have a look at the overall summary of what's happened. So we've had 4 phases. There's the first phase where basically it was the first time COVID was anywhere in the world, followed by a second wave, which was predominantly in Melbourne. Then we had this extended phase where there was really little or no activity. This was through our summer, and then we've got this, effectively it's a 4th phase, maybe it's a 3rd wave, which is happening here in Sydney. And from what I've seen around the world and from the data that I'm analysing, these things don't look the same as previous events. And so my frustration is that the government seems to be responding as if it's the same, whereas the reality is it's not the same. So with that in mind, I've been developing this report, and I've got this small multiples report, which I built last time. And so now I can have a standard starting position. So I've started the phase at the point where the 10th infection was recorded. So there's a standard starting point, and from then on I followed the pattern of the new cases and the pattern of the deaths. And clearly you can see these are similar in nature, but they're not the same. This lead lag slider, this death lag slider if you like, is particularly useful because it allows me to take the reality of when the cases start and then when the deaths come in, and then adjust for the apparent lag between when people first start to record getting sick and when they actually, those that unfortunately die, actually do die. Now you can see here that there's something different going on, and what I'm going to do today is I'm going to change this report. So I'm going to keep this one, many different ways to view data, but I'm going to try and rebuild something where I can select 1 or 2 phases, and then I want to be able to overlay the activity around the cases and the deaths on the same chart so that we can compare whether these different phases are the same. So what I've done is I've just taken a straight copy of that page. I'm calling this one the phase trends compared. And I'm going to take a new approach. So I'll take this and break it down. I always like to try and start with something that I've previously done. It just makes it a little bit easier. It means you don't have to start from scratch. And I think what I'll do is I'll start off with new cases. I'll get rid of the small multiples. So now I've got new cases. I'm going to go to a straight line chart this time. And I will just clear everything off. I'll put the new cases as the values, and I'll bring the phase in as the legend. So this will allow me to overlay the phases, remembering that I have a common starting point for each phase, which was the day of the 10th infection. So now I should be able to select 2 phases of interest. So phase 4, phase 2 are the ones that I particularly care about. And now we're starting to see some clear demonstration of what's going on. Now, a couple of observations here. First of all, this is telling me phase 2, phase 4. So that was quite useful early on, but now I think I'd like something a little bit more descriptive. And then the second thing is that these curves are very sawtooth, and I think that's a reflection of weekends and things like that, so people don't always get tested on the same day. So I think I need to fix those 2 issues before I move on to anything else. All right, so let me fix the naming first. So as I recall, if I go back into my query, I hard-coded this data. So let me come back here. So here's my staging phases. Giving tables good names is useful, so that I come back here. So I'm going to come into this first step, and I'm just going to give each phase a name. And so phase 1, I'll just call that, this is a bit arbitrary. So that's the first wave. I'm going to call this the Melbourne wave. And the 3rd phase, I'm going to call it all quiet. And then the 4th phase, I'm going to call Sydney wave. All right, now I've still got this phase column, so I can actually sort this column based on this column. So at least they will be in the right order. So click OK, make sure I don't have any remove other column steps. In fact, so I've still got their names there, expanded. All right, so that's all good. And I do need to bring this name into my calendar table as well. So I need to find the point where I merged the phases. There it is. And then I expanded, and when I expanded, I brought out the phase. I want to bring out the name as well. And so I think that should give me days. So let's make sure I've got this here. If you're ever struggling to find a column that you're looking for, this is a great button, this choose columns or go to columns. If I come in here and I can actually run this alphabetically. So there's my phase and I can't see the name. This is where I put the numbering down. So then I merge the queries. This is where I joined the phases, and then this is where I extracted the phases. It's called name. Aha, here it is. So when I did this expanded count step, I did not expand the phase. That's right, because I already had the phase, but now this new column exists. I need to go back and do it again. Hey, this can happen. So as I said, this is DAX in the trenches. So this is the way things happen in real life. All right, so this, I might give this a better name. I'll call it phase name. I should have done that earlier on, but I'm not going to go back and do it now. And let's call that a text. And I'll leave that as null. I think that's fine. All right, so let's go ahead and load that up. Sort my phase column, my new phase name column by the phase column because they're the same level of granularity, and the phase column will sort alphanumeric automatically. And so I will replace the phase name in here, and I'll sort the phase name based on the phase. I've put it in the wrong one, but that's okay. I need to do both of them anyway, so it's no big deal. All right, so I think that's better. I need a little bit more real estate over here because the names are a little bit wider, but I can sort that out later. All right, I think what I will also do is I'll just add a slicer here. There's different ways you can do this. I'll just do a drop-down slicer, and I'll allow the end user to choose the phases that they want. This works this way because in this particular case I'm using this chart has a legend, and so this straight filtering behavior is actually pretty much what I want. So I'll just put that up here. I will set this one to multi-select. It'll just make it easier. So multi-select is on with control. I want it on without control. So Melbourne and Sydney, and you can see they're in chronological order. Well, if you're from Australia, you would know that. I'm just going to inherit the, I might as well just come over here and format the shading. I know some people don't like that, but I do. All right, so let's stick that up here. Just trying to make things align a little bit. You know, you'd be surprised the difference in the look and feel of a report if you just try and get the gaps the same space apart and get everything lining up. It does make a big difference, much more pleasing to the eye. It's not everyone's cup of tea, but if you can just put a bit of effort in it, it just looks a little bit better. I also can just tell I'm missing a light grey border here, which I'll just come and apply. I've got a feeling I use this one here. All right, so that all looks pretty good at this point in time. All right, so let's have a look at the two phases compared. And now we've got this sawtooth issue, which I'd really like to address. And this, once again, is a time intelligence problem. I think what I'd like to do is take a rolling 7-day average. That seems to be as good a number as anything. And so this is a time intelligence problem. So let's check which measure I've got. I've got the new cases measure. And so I'll do a new measure. I should change that name. I don't like new cases. But anyway, let's call it total cases 7-day average. I should put a space in there. So total cases 7-day average. Okay, so this is a standard calendar table, so I can use the inbuilt time intelligence functions. The x-axis of this chart is not using the date, but it is using the day number. So just let me show you what I'm going to do here. I'll just put 1 here for now. So I just want to explain what I'm about to do with this time intelligence function. When I come to the calendar table, if I pick a phase, So let's say phase 4, which is Sydney. And then I come to this day of phase, whatever that was called, over here, day of phase. If I pick a particular day, so in other words, if I filter for one of the days in this phase, I'll take day 17, notice that there's only a single date left in the calendar table. So with the combination of a phase filter and a day in phase filter, there's only a single date left inside the calendar table. And so I'm going to use this fact to help me write this time intelligence function. Okay, so I'm going to write a custom time intelligence function to solve this problem. And I'm going to use variables. It just makes it easier to explain. It also makes it easier to debug and check and just make sure I'm doing the right thing. So the first thing I need to know is what is the date that at any particular point occurs. So for day 45, what is the date? And so to do that, I will do var, and I'll call it, just give it a good name so that you understand what it is. What is the date of the data point? So given the axis is putting a filter on the day in the phase, and the legend is putting a filter on the phase name, once those two filters get applied, there'll be a single date. And so I can just say something like max of the date. That'll do. I could also use selected value. I could use min of date. I could use pretty much whatever I want because there is only a single date at that point in time. So now I know what the date is up until which I want to do the 7-day average. And so I need to select a period in time that will allow me to get that 7-day period. Now there is an inbuilt time intelligence function that I think I can use here, and I'll use a variable again. I'll call it my 7-day period. Now with variables, you can't start with a number. I can't go 7-day period like that. I have to go something like 7-day period. And so I need a table function, a table containing the 7 days that I care about, and that's dates in period, calendar date. So anytime you see the dates parameter, it's always the calendar date, the date column in your calendar table. I want to start from the date for data point, and I want to go back, so -7 day. All right, so that should give me a table consisting of the 7 days in the period. And then I'm going to return, and I'm going to calculate. I need the new cases, all except. This is not a function I use very often, but in this case, it might be pretty useful. I want to remove all the filters from the calendar table, but I must keep the filter on the phase. So all except from the calendar table except for the phase. And in fact, it's the phase name. So I might do both just in case I choose to change it or I use some other filter somewhere else. So I'm going to keep the two filters on the phases, and then I'm going to use the 7-day period table, which I created up here. I might just do a quick test first. Always good value to test. So I'll bring a setup over here. I might bring the date in. I'll just pick one of these waves. So I'll bring the date in. There's the 7-day rolling. Here's the new cases. Now something's wrong here because we should not have 86 cases at this point in time. So let's just do a quick maths. 26, 34, 41, 49, 59, 66, 85. So that number's correct, 85, but these numbers are not correct. So these dates must be picking up dates in the previous period. So let me just do a quick little test measure here. Now, because I actually don't quite understand what's going on here, I'm going to come back to my total 7-day cases. I suspect that this function is grabbing dates from previous periods. So I'm not 100% sure, but this is a table containing dates. And so I'm going to turn this into var results so I can come back and use that later. And then I'll do return. and I'm going to go concatenate X, step through the 7-day period table, and for every row in that table, grab the date and concatenate it if there's another one with a comma space. So what this little test measure will allow me to do is to check what dates are included in this calendar table, and I particularly want to check for these first few dates. So let's just have a look at what's going on here. So there it is. So on the 1st of the 6th, interesting, the dates have flipped to the American format, but I have confirmed exactly my suspicion. So even though the first date in the period for the Sydney wave is coming on the 1st of the 6th, this dates in period calculation has gone back into previous periods and grabbed those as well. And that's actually not what I want. Now, I expect what the issue is that this is related to the fact that I'm using an inbuilt time intelligence function, and effectively this is a non-standard calendar table. Now, what I mean by that is that I've got this phase name, which is part of my calendar table, and I suspect that this dates in period function is ignoring that phase name filter, which I need it to respect in order for this to work. So I need to do something different. So I'm going to use a custom time intelligence function instead. So just to make it clear what I'm doing, I'm going to write another variable. And so basically I need to write a filter that says, give me the dates from this date to that date. So I need a date start from, and I'll just put equals 1 at the moment. And I'm going to rename this one date end on. So I've now got an end on this date, start on this one, which will be date end on subtract 6. Note before I use 7 inside the dates and period, that automatically covers for the first day and the last date in the period. But if you're doing custom time intelligence, you have to subtract 1 so that you get the right number of days that we deliver back. All right, so I've got my start date and my end date. And so now I can turn this into a table of dates. Now, I need to filter the calendar table in 2 places. I need to filter it on the date column, and I also need to filter it on the period. So I think I could just go filter, in fact, all of the calendar dates. So just give me the column of dates, and I need to put 3 filters. I need the date to be greater than or equal to the date start on. And I need the calendar date to be less than or equal to the date end on. And I just realized I can't refer to the period because I don't have it here. So I need to come back and put phase in here. In fact, I'll put the phase and the phase name. In fact, I do need them both because I'm sorting phase name based on phase. So I definitely need both of those in there. And I also need this to be the phase name. And because it's inside a filter function, and technically a filter function's got a row context, I can say phase name is equal to, and I can just use that same trick as before, max of the phase name. So make sure I've got a matching pair. I think this is going to be okay. Sometimes it's a bit of try it and see. I might just put a new line in here, make it easier to read. So let's see whether that does what I need to do. I need to have 1 day, then 2, then 3, 4, and 5. All right, good. So that's working now. So now I've got my 7-day period is actually a ramping in 7-day period. So after 1 day, it's only going to be a single day. Then it's going to be 2, 3, 4, 5. And in fact, I've just realized that I haven't done a rolling day 7 average. I've actually done a cumulative 7-day average. So let me come back and return the result. Let's have a look now. All right, so now this is looking correct. So 12 cases, 12 running total, 14 is 26. So this is not a 7-day average at the moment. It's a 7-day cumulative total. I need to change that to a 7-day average. But if I divide this number by 7, it's going to be 12 divided by 7, and that's incorrect. I need to divide 12 by 1, 26 by 2, and then 34 by 3, and so on. And so if I count how many rows in this table, I'll know which number I need to divide by. And so I'm going to return divide the result by count rows of the 7-day period table. I could improve this a little bit by breaking out some of the measures and making it a little bit more self-documenting. Let's have a look. So 12, so 14, I've got this rounded, so I probably at this stage should come up and add a decimal place. So 12, 14, the average is 13, that's correct. 34 divided by 3 is 11.3. So that would appear to be working. And also another good way to check is to actually overlay. I'm done with this now, I can get rid of that. If I actually overlay my 7-day rolling total with the daily totals, it should actually give me a nice visual indicator. So let me move that back up here. In fact, I don't think I can do that if I have a legend. So I'll get rid of the legend and now I'll put multiple here. And yeah, so that's really useful. You can see how the 7-day rolling total is actually smoothing out that otherwise jagged number. All right, so I think that's what I need. So I'm going to remove that. I'll bring my phase back in. And I want the phase name as the legend. And then if I basically turn on Melbourne and Sydney, now I can see over time, based on a common starting point, the day of the 10th infection, you can clearly see that these two waves are not the same. Much steeper growth in Melbourne in wave 2 and much flatter growth in Sydney. So they're the cases. I think what I would like to do here is I want this table to show me all the data. I want this filter to apply here. So I'm going to come up to format and change the edit interactions. This slicer should not impact this table. I want to keep this table preserved, showing all the data. All right, so that's one of the data points. I'm not quite sure how I'm going to lay this out yet, but I'll just move that up out of the way. And I now want to do the same thing for the deaths. And so I'll copy this, Control C, Control V. I'll go through the same process. Let me start off by bringing the deaths. I want to keep the offset, the lag so this is the one that I created, the deaths at equivalent days in. So that looks like it was pretty close for a period of time. I might just go and check that. That doesn't seem quite, oh, okay, no, that's not what's happening. Well, I think what's happened is that the Sydney wave basically had nothing until this data point here. So basically the death started early on in Melbourne. So it's not that they were tracking the same, it's that there were none in Sydney. All right, I'm going to turn this to a stacked bar chart. I want to keep some consistency between the way this looks on the other pages and here. I'll leave the colors for now. What I don't think it's going to make any sense to do a rolling 7-day average in this case, so I'll just leave it like that. And so yes, I will jump in here and do the colors. And so we'll have Victoria can be blue, and for Sydney I'll bring in a good New South Wales blues color. And so I think that gives me a good representation now of how the deaths are performing over time and how the rolling average of the 7-day cases are performing. I think what I'll do is I'll put a title on this chart. Just hit reset on that one. So yeah, 7-day average. It's probably a little bit verbose. So I think I'll completely replace this with total 7-day rolling average cases. Okay, I need to change the colors up here. So I want the colors up here to match the ones down the bottom. So I'll come down and I'll put the same blue. Although now I think about it, these colors are a little bit arbitrary because I'm going to be able to apply a filter up here and they won't necessarily make any sense once that happens. Okay, now we've got a new problem because the axis down here is not matching the axis with the one at the top. I actually want to keep the cases, the forward case view there for Melbourne, because I want to be able to see what actually happened. And so I'm just wondering what would happen if I turn this back into a combo chart and just see whether I can configure this so the column series. See, once I do this, I lose the opportunity to have a legend, so that's a bit of a problem. Yeah, so that's not going to work. So, as much as I want to keep this Melbourne trend, I just don't see a way of making these two axes automatically align unless I get rid of this forward day. So I'm going to just try this out. I'm going to create the 7-day average cases, but I'll create a version that stops at the last data point. I've already written that within this one, so let me go and have a look at this one. So this is the more complex formula. You should definitely be reusing your formulas. So I'm going to put a new measure, and this will be effectively rolling 7-day average cases to the last data point. I'm not sure that that makes a lot of sense. I'll paste that and then I can get rid of the other name. So the formula should be the same, except when I come to do if selected value, this is, instead of being those deaths, I need it to be the total 7-day average. So let's have a look and we'll soon see. So I'll try and swap that with the new measure. Okay, and that looks a lot better to me now. So because we've got the same values on the x-axis on this top chart and the bottom chart, and I've basically sized them correctly, and I've got both charts starting at 0, I'm able to align those axes, and now you can clearly see the Melbourne wave at the top. Their rolling average cases is going up, and you can see the deaths responding to that. Of course, this has been adjusted by 19 days. And then you can see the Sydney wave that's coming through now, and you can clearly see that the death rate is not at the same orders of magnitude. In fact, if you come over here, Melbourne's death rate at this point was 3.5% of all cases, and Sydney is 1.2. So it's about 3 times less fatal than the Melbourne wave.